In this lesson, we officially start a lot of our calculus section with a key concept called the derivative. And the derivative is the slope of the tangent line at any point on a curve. And we are going to use a limit-based formula, and the picture shows kind of where the formula comes from. And I'll explain the formula as we go through. So we start with a given point, an xy ordered pair here, where an x and f of x are x and y. And then we're going to add some distance h, which creates our new ordered pair. We're going to join the points, and a line that intersects the curve in 2 points is called the secant line. Then what we're going to do is take the distance h, we're going to shrink that distance, have it approach 0, so the 2 points would move closer together, eventually being a single point, and the line through this point would be the tangent. And the derivative is finding the slope of that line. And other notations, we can use f prime of x for the derivative, dy dx, which means the derivative of y with respect to x, y prime, and a d over dx, which is the derivative of x of our function. So using the limit-based definition, which is up here, everywhere we see an x, we're going to plug in an x plus h. Now, a couple things. One, you need to write the word limit until you're ready to plug it in. So here's our first step. So we're going to say limit as h approaches 0. The first part of my function is x cubed. So I'm going to do x plus h cubed plus 2 times x plus h. So notice everywhere I see an x, I put in an x plus h, and then minus f of x means put a minus, parentheses, because my function is not a single term, like that, all over h. And in the last module, we talked about limits, and our first strategy is, can you plug the 0 in? You cannot. So we come to the next step where we're going to multiply out. And so the cubic x cubed plus 3x squared h plus 3xh squared plus h cubed, and then plus 2x plus 2h, and then I'm going to distribute the negative sign, minus x cubed, and then minus 2x, and we're going to put all of that over h. And as we're looking at our expression, now we're going to see what cancels. So the x cubed and the x cubed, and the 2x and the 2x. Okay, so let's see what's left. Now, limit h approaches 0. I'm left with 3x squared h plus 3x h squared plus h cubed plus 2h all over h. Now, I still can't plug in the 0, so our next strategy is to factor. I'm going to take an h out of everything on the top, and so when I do that, I'm left with 3x squared plus 3xh plus h squared plus 2h. Actually, it's h squared, let's see, x squared, 3xh. I've been on quarantine too long. Sorry, guys. Okay, so h squared, and then plus 2. All right, all over h. And then the h's will cancel. And now I'm left with limit h approaches 0, 3x squared plus 3xh plus h squared plus 2. Now I plug in the 0, so there's no 3x squared, 3x times 0 0 squared plus 2, and we end up with 3x squared plus 2, and that is our derivative. So we then would write f prime of x equals 3x squared plus 2. So there's our derivative. So couple notes to self. You must write limit as h approaches 0 until you can plug in the 0. Okay, so the rest of the lesson now are just going to be more examples. And so now what we're going to do, the next thing is, sorry about that, we are going to find the derivative at a point. So that means use the definition and then plug -1 into the derivative. So we're going to find f prime of x and plug in -1. So what it creates is a formula to find that slope at any point on our curve. All right, here we go. So limit h approaches 0. I start with x squared, so x plus h quantity squared plus 2 times x plus h, and then minus the function x squared plus 2x all over h. So again, now we can see the process. Can't plug in the h, got to multiply out and try to cancel. Limit h approaches 0, x squared plus 2xh plus h squared plus 2x plus 2h, and then we distribute minus x squared minus 2x all over h. Okay, now we look to cancel. So x squared and x squared, 2x, and the x's cancel. So now I'm left with limit as h approaches 0 of 2xh plus h squared plus 2h all over h. I still can't plug in the 0, so I'm going to factor on the top. The h comes out, 2x plus h plus 2, and the h cancels on the bottom, and I'm left with limit as h approaches 0 of 2x plus h plus 2. Now I can plug in the 0, so 2x plus 0 plus 2, and that's 2x plus 2. So my derivative, f prime of x, is 2x plus 2. So that's my derivative. And now over here, we're going to finish up what we wanted to do, which we want f prime of -1. So 2 times -1 plus 2, and that gives us a 0. So this means, you don't have to write this down when you do the problems, but here's what it means. The slope of the tangent line at x equals -1 is 0. So that happens to mean at that point, because the slope is 0, it's a horizontal tangent line. And not every tangent line is going to be horizontal, but if you get the value 0, then you know that slope is 0 and it's horizontal. Okay, now finding the equation of the tangent line is a 3-step process. So 1, you're going to find the derivative, and then at x equals -1, that's the slope, and then 2, you're going to find f of -1, and that's going to give you the y coordinate to give you the point xy. Plug that into the original function. And 3, you're going to use point slope, which is y minus y1 m x minus x1 to find the equation of your line. Okay, so here we go. So first we'll find the derivative. So limit h approaches 0. I've got x plus h quantity squared minus 5 times x plus h minus x squared minus 5x all over h. We try to plug in the h, we can't, and so we're going to have to multiply out just like the prior 2 examples. Limit as h approaches 0, x squared plus 2xh plus h squared minus 5x minus 5h minus x squared plus 5x all over h. And now we look to cancel. Your terms only with x's should be what cancels each time, just kind of a benchmark to know that you're doing it correctly. We'll see if I can shave a step here because these do take a long time. Notice what's left. I can pull an h out of everything. So that's going to give me 2x plus h minus 5 all over h. Those are going to cancel. Then I can plug in the 0. So 2x plus 0 minus 5. So that means my derivative is 2x minus 5. So that shows you a little bit how you can condense some of the steps once you get comfortable in your algebra. So now we're going to find f prime of -1. So 2 times -1 minus 5, that's -7. That's the slope of our tangent line at that point. Okay, now I need to find f of -1 for the y coordinate. So -1 squared minus 5 times -1. And that's going to give me a 6. So I've got a -1 and a 6. And that's the point. And then now I'm going to use point slope. So y minus y1 m x minus x1. And the y there from my point is a 6. My slope is a -7. X plus 1. And then y minus 6, -7x minus 7, and y equals -7x minus 1. And that right there, oops. Sorry about that little shift there. That is the equation of the tangent line. There we go.